Hi guys! In the previous video, we learned how to graph parabolas of a given equation. Today, we're going to learn how to get the equation when given some points on the parabola. Before we start, please subscribe to our channel and don't forget to click the bell button to turn on notifications, because more incredible content is on its way. Okay, let's get started. In the first example, there are 3 points on the parabola of the quadratic function. 0 and 3, 1 and -1, and 2 and -3. What is the expression of this function then? As we already learned, the general form of the quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So all we need to do is plug in the coordinates of the points onto the function and get the equation system with 3 variables. When we plug in x equals 0 and y equals 3, the x coordinate and the y coordinate of the point 0 and 3, we get 3 equals c, or c equals 3. We plug 1 and -1 into the function and get -1 equals a plus b plus c, or a plus b plus c equals -1. We plug 2 and -3 into the function and get -3 equals 4a plus 2b plus c, or 4a plus 2b plus c equals -3. Now we get the following equation system. C equals 3, a plus b plus c equals -1, 4a plus 2b plus c equals -3. Next we plug c equals 3 into the other 2 equations and get a plus b plus 3 equals -1 and 4a plus 2b plus 3 equals -3. These equations can be simplified into a plus b equals -4 and 4a plus 2b equals -6. Does it look familiar? Well, that's because we've already learned these 2 methods to solve these kinds of equation systems: elimination and substitution. You can check out the link in the description if you want to get a warm-up. Here we will use the elimination method to solve this equation. Multiplying 2 on both sides of the first equation, we get 2a plus 2b equals -8. When we subtract the first equation from the second equation and get 4a plus 2b minus parentheses 2a plus 2b equals -6 minus -8. 4a minus 2a equals 2a. 2b minus 2b equals 0. -6 plus 8 equals 2. That's 2a equals 2, so a equals 1. Plug a equals 1 into the equation, a plus b equals -4, and get 1 plus b equals -4, so b equals -5. Now we have a equals 1, b equals -5, and c equals 3. So the expression of the function is y equals x squared minus 5x plus 3. In the next example, the vertex of the parabola is 2 and -1, and the point 4 and 3 is also on the parabola. What is the expression of the quadratic function? We already know the function is in the form of y equals ax squared plus bx plus c, and when x equals -b over 2a, the function has a vertex. So we get -b over 2a equals 2. Multiplying -2a on both sides, which can be simplified to b equals -4a, we then plug the coordinates of the points 2 and -1 and 4 and 3 into the function and get the equation system. Equation 1, b equals -4a. Equation 2, -1 equals 4a plus 2b plus c. And equation 3, 3 equals 16a plus 4b plus c. As we can see, only 2 equations have the variable c in it. We can get rid of it by subtracting equation 2 from equation 3 and get 4 equals 12a plus 2b. All the terms have a common factor of 2, so the equation can be simplified by dividing 2 on both sides and getting 6a plus b equals 2. From equation 1, we know b equals negative 4a, so we substitute b equals negative 4a and get 6a plus negative 4a equals 2. That's 2a equals 2. As a result, we get a equals 1. Next, we plug a equals 1 into the equation 1 and get b equals negative 4. Then we plug a equals 1 and b equals negative 4 into the equation 2, and it becomes negative 1 equals 4 plus 2 times negative 4 plus c, which is negative 1 equals 4 minus 8 plus c. So we get c equals 3. So now we know the expression of the function is y equals x squared minus 4x plus 3. Let's look at another example. The point negative 1 and 12 is on the parabola of the quadratic function y equals x squared minus 6x plus c. What is its symmetric point on this parabola? In this example, a and b in the function are already known. That means we just need to plug in the points negative 1 and 12 and then get the value of c. The function becomes 12 equals negative 1 squared minus 6 times negative 1 plus c. Remove the parentheses and we get 12 equals 1 plus 6 plus c. So c equals 5. The expression of the function is y equals x squared minus 6x plus 5. As we already learned, the axis of symmetry of the parabola is x equals negative b over 2a. Here, x equals negative 1 times negative 6 over 2, which is x equals 3. Next, we graph the function. The symmetric point of negative 1 and 12 has the same y-coordinate, 12. When we look at the parabola, we can find the distance between the symmetric point and the symmetric line, d1, is the same as the distance between the points negative 1 and 12 and the symmetric line, d2. Here, d2 is the difference of 3 and negative 1, which is 4. d1 is the difference of x and 3, so we plug in x minus 3 equals 4 and get x equals 7. This means the symmetric point of negative 1 and 12 is 7 and 12. Okay, now let's focus on the vertex again. Understanding vertexes is very useful. It can be used to solve many problems in area of maximum and minimum value. Let's look at another example, which will also be the last example of this video. The sum of two numbers is 60. What is the largest value of their product? We assume one number is x and the other number is 60 minus x. So the product is x times parentheses 60 minus x equals negative x squared plus 60x. This is the quadratic function with a equals negative 1, b equals 60, and c equals 0. We already know the function has a vertex when x equals negative b over 2a. Furthermore, a is less than 0 in this function. Therefore, the function has a maximum value when x equals negative b over 2a. Plug a equals negative 1 and b equals 60 into x equals negative b over 2a and get x equals 30. The last step is to plug x equals 30 into the function. It becomes y equals negative 30 squared plus 60 times 30 equals 900. That means the largest value of the product of the two numbers is 900. We're all done. Okay, I think we've learned enough for today. Thank you for your attention. If you have any questions, leave your comments below or email us at question@beat-math.com. We'll try to answer your questions in a future video, and the most common question will be given priority in our next video. See you next time!